Look at two graphs showing the same data. One looks calm, the other looks dramatic. You feel different things, even though the numbers are identical. That reaction is exactly why graphs can lie. A graph is a translation. It takes numbers and turns them into position, length, color, or area. If that translation is distorted, the message changes, even when the data are real. Graphs rarely lie by inventing numbers. They lie by how they show true numbers. Start with the most common trick, the axis. In a bar chart, height is meaning. If the y-axis doesn't start at 0, the bars stop representing actual size. A change from 54% to 62% is 8 points. That's modest. But if the axis starts at 50 instead of 0, that same 8 points fills most of the chart and feels huge. The data didn't change, the story did. Uneven scales do the same thing. If one step on the axis represents 20 units and the next step represents 5, your eye assumes they're equal. Slopes, gaps, and jumps stop meaning what they appear to mean. Then there's aspect ratio. Stretch a chart vertically and a gentle trend becomes a spike. Compress it horizontally and volatility disappears. Nothing about the numbers changed, only the geometry did. Dual axes are another favorite. Two lines share the same space but use different scales. With the right axes choices, unrelated trends rise and fall together, suggesting a relationship that may not exist. A simple test helps. Cover one axis. If the relationship falls apart, the chart was doing the convincing, not the data. Next is selective storytelling. You can make almost any trend look good or bad by choosing where to start and stop. Show only the last 6 months and ignore the last 10 years. Use a cumulative chart that always goes up even when current performance is falling. The data can be technically correct while the conclusion is deeply misleading. Now consider denominators. Counts feel concrete, but they're often the wrong measure. Saying one city has more crime than another is meaningless without population. Rates exist to make comparisons fair. Whenever you see numbers, ask per what and out of how many. Averages hide a lot. Two groups can share the same average and live very different realities. One tight cluster, one widespread. When graphs show only the mean, they erase variability, outliers, and subgroups. Sometimes combining groups can even reverse the apparent result. The overall trend says one thing, while every subgroup says the opposite. The average person, statistically, often doesn't exist. Design choices matter too. Humans compare lengths well, but we're bad at judging area and terrible at judging volume. If a value doubles and the graphic doubles in height and width, the area quadruples. That exaggeration feels intuitive, but it's wrong. Three-dimensional charts add perspective distortion and hide information. Pie charts only work when slices represent parts of a whole that sum to 100%. Otherwise, they're not just confusing, they're incorrect. Color can push emotion. Bright reds imply danger. Faded grays imply insignificance. Non-linear color scales can make small differences look extreme. None of this changes the data, but it changes how you feel about it. Even a perfectly drawn chart can mislead if it lacks context. No units, no time period, no source, no definition of what's being measured, no uncertainty. Without that information, you can't judge accuracy or relevance. It's like reading a nutrition label with the numbers removed. Why does this work so well? Because visuals hit first. Your brain reads shape and size instantly. Numbers come later, if at all. Chart designers, sometimes intentionally and sometimes by accident, exploit that gap. So here's a simple way to read graphs intelligently. Check the axes, check the units and denominators, ask why that time window was chosen. Watch out for dual axes and 3D effects. Ask whether you're seeing counts or rates, means or distributions. look for what's missing. And be cautious when a chart implies causation just because two lines move together. Finally, if you make graphs yourself, honesty is a choice. Match the chart type to the question. Use consistent scales. Show uncertainty when data are noisy. Provide context. Clarity beats persuasion. The goal isn't to distrust graphs. The goal is to slow down just enough to see what the picture is really saying and whether the data actually support it.